Bismillahirrahmanirrahim. Dear students, Assalamu alaikum. I am Dr. Azhar Ali, Assistant Professor, Electrical Engineering Department, Sarhad University, Peshawar, and you welcome back to this study. Dear students, in this first video lecture of Week 8 for the course Biostatistics 1, today we are going to revise the topic measure of dispersion for paretics by using some problems. So, dear students, we have already learned that the extent or degree to which data tends to spread out around an average is called the dispersion or variation. Measure of dispersion helps us in studying the extent to which observations are scattered around the average or central value. The types of measure of dispersions. There are two types of measure of dispersion. Number one, absolute measure of dispersion. These are expressed in the same unit in which the observations are given. Thus, absolute measure of dispersion are useful for comparing variation in two or more distributions where units of measurement is the same. Such measures are not suitable for comparing the variability of the distributions expressed in different units measurement. The absolute measures are range, quartile deviation, mean deviation, variance, and standard deviations. And second one is the relative measure of dispersion. These are expressed as ratio or percentage or the coefficient of the absolute measure of dispersion. Relative measures are useful for comparing variability in two or more distributions where units of measurement may be different. So, the relative measure of dispersions, the following are relative measure of dispersion. Number one, coefficient of range, coefficient of quartile deviation, coefficient of mean deviation, and coefficient of variation. So, dear students, in this first video lecture of week 8, we will learn about the coefficient of range and coefficient of quartile deviations. In the second video lecture, we will learn about the coefficient of mean deviation and coefficient of variation. Now, what is range? Range is the smallest measure of dispersion. For a given set of observations, the range is the difference between the largest and the smallest observation. Thus, range denoted by R, and this R is equal to L minus S, where L is the largest observation, S is the smallest observation, and R represent the range. In case of group data, the range is defined as the difference between the upper limit of the highest class and the lower limit of the smallest class. And the coefficient of range. Range is an absolute measure of dispersion which is unsuitable for comparing variation in two or more distribution expressed in different units. So, a relative measure of dispersion called the coefficient of range and is defined as coefficient of range is equal to L minus S divided by L plus S. Now, for example, we have a problem. Marks of 10 students in mathematics and statistics course are given as. So, these are the marks of students in mathematics, like the marks of the first student 25, second student's marks is 40, third 30, fourth student marks is 35, fifth student marks 21, sixth student's marks 45, and the marks of seventh student is 23, marks of eighth student is 33, marks of ninth student is 10, and the marks of 10th student is 29. And so these are the marks of these 10 students in the statistics course, like 30, 39, 23, 42, 20, 40, 25, 30, 18 and 19. So dear students, I have already told you that actually measure of dispersion mean that which one data is consistent. We compare the two data, and in this example you see over here marks of mathematics of 10 students are given, and marks and statistics course of 10 students are given. So we are going to compare these two data. So by using the range, compare the marks of these two courses and comparing the coefficient of range for both the subject for both the courses. So solution: highest marks in mathematics is 45 and the lowest marks in mathematics is 10. So first of all, find the range for the mathematics course, for the marks of mathematics course. So the highest marks is 45 and the lowest marks is 10. So largest minus smallest, 45 minus 10 is equal to 35. So the range in the marks of mathematics is 35. Now the coefficient of range for the marks of mathematics: L minus S divided by L plus S. So 45 minus 10 divided by 45 plus 10, which is equal to 0.64. Now to find the range in the marks of statistics, so the largest marks in statistics course is 42 and the lowest marks in statistics is 18. So the range of marks in statistics is equal to R, and R is equal to L minus S, which is equal to 42 minus 18 is equal to 24. Now the coefficient of range for this marks is L minus S divided by L plus S is equal to 42 minus 18 divided by 42 plus 18, which is equal to 0.4. Now dear students, note that the range always is the coefficient of the range for the marks in mathematics are higher than that of marks in statistics. So the statistics data is consistent. Dear students, you see over here the range in the mathematics marks 35 and the range in statistics marks is 24. So the range of statistics marks is less than the range of mathematics marks. And similarly, the coefficient of range in mathematics score is 0.6 and the coefficient of range in statistics score is 0.4. So it's mean that the marks in statistics scores is consistent. So this is actually called measure of dispersion. Now another problem, to find the range and coefficient of range for this data. Now this is the group data. You see over here mid values 5 and the frequency is 7. Similarly, next second value is 10 and frequency is 5. Value 15, frequency 8. Value 20, frequency 12. Value 25, frequency 8. Value 30, frequency 9. Value 35 and frequency 8. So you see over here these are the values and these are the frequencies of the values. So dear students, if we construct the classes for this data, we use these classes 2.5 to 7.5 and 7.5 to 12.5 and so on for this class, for this class, for this class and for this class. And the last class will be 32.5 to 37.5. I have already told you in the previous video lectures that how we can construct the classes form, the group form for a given ungrouped data. Now in this data actually values are given, the mid values of the class are given and the frequencies are given. So these will be the classes for this mid values: 2.5 to 7.5, 7.5 to 12.5 and so on, 32.5 to 37.5. Now I have already told you that the range for the group data is given by the largest value of the highest class and the smallest value of the lowest class. This is actually the largest class. The largest class, highest value of the largest class is 37.5, and the smallest value of the lowest class is 2.5. So 37.5 minus 2.5 is equal to 35. So this is the range for this group data. Now the coefficient of range is equal to L minus S divided by L plus S. So 37.5 minus 2.5 divided by 37.5 plus 2.5, which is equal to 0.875. Now another measure of dispersion, which is called interquartile range and quartile deviation. Interquartile range includes the middle 50% of the distribution, or it is the difference between the third quartile and the first quartile. Like you see over here, interquartile range is equal to Q3 minus Q1, and quartile deviation or semi-interquartile range is defined as the average amount by which the two quartiles differ from the median. And quartile deviation or semi-interquartile deviation, semi-interquartile range is given by Q3 minus Q1 divided by 2. So quartile deviation is an absolute measure of dispersion. For comparing two or more distributions in respect of variation, the coefficient of quartile deviation is defined as, like you see over here, Q3 minus Q1 divided by Q3 plus Q1. For example, from the following information of wages of 15 workers, find the interquartile range, quartile deviation, and coefficient of quartile deviation. So in this problem, dear student, you see over here, these are the serial. This is the serial number. Serial number mean that there are 15 wages. 520, 550, 440, 580, 450, 620, 470, 680, 400, 490, 420, 480, 440, 480, and 500. So these are the 15 wages. Now, dear students, you see over here, first of all, arrange the wages in ascending order. So the ascending order of the wages, like you see over here, start from 400, and at the end the last value is 680. This is the ascending order of the wages. Now first of all, find the first quartile. The first quartile position is equal to n plus 1 divided by fourth position. So since there are 15 items, so 15 plus 1, 16, and 16 divided by 4 is equal to fourth item. And the fourth item in this data, you see over here, this is actually the fourth item, 440. So this is the first quartile. Now the third quartile is given by 3 n to n plus 1 divided by fourth term, and when you put n is equal to 15, so 15 plus 1, 16, 16 divided by 4, 4, and 4 multiplied 3, 12th term. And the 12th term in this data, you see over here, this is actually the 12th term, 550. Now the interquartile range is equal to Q3 minus Q1, and Q3 is equal to 550 minus 440 is equal to 110. And now the quartile deviation is given by Q3 minus Q1 divided by 2. So Q3 value is 550, and Q1 value is equal to 440 divided by 2, and after simplification we obtain the quartile deviation is equal to 55. Now the coefficient of quartile deviation, which is given by Q3 minus Q1 divided by Q3 plus Q1. The Q3 value is 550 minus 440 divided by 550 plus 440, and after simplification we obtain the coefficient of quartile deviation is equal to 0.11. So dear students, now the next problem is to calculate the quartile deviation and its coefficient from the following distribution. Like you see over here, weekly income is given 58, 59, 60, 61, 62, 63, 64, 65, and 66. In number of workers, 2, 3, 6, 15, 10, 5, 431. So actually these are the terms of the data. In number of workers mean this is actually the frequency. Now how we can calculate the quartile deviation and group distribution data? Like you see over here, first of all write the values. These are the weekly incomes: 58, 59, 60, 61, 62, 63, 64, 65 and 66. So dear students, note that number of workers mean frequency: 2, 3, 6, 15, 10, 5, 4, 3, 1. Now for this data we need the cumulative frequency. Cumulative frequency represent the position. So for to construct the cumulative position, write the first frequency as it is. You see over here 2, and now 2 plus 3 5, 5 plus 6 11, 11 plus 15 26, 26 plus 10 36, 36 plus 5 41, 41 plus 4 45, 45 plus 3 48, and 48 plus 1 49. So it's mean that the total number of workers is 49. Now you see over here, to find the Q1 quartile, first quartile, n plus 1 divided by fourth term. So 49 plus 1 50, and 50 divided by 4 is equal to 12.5. So the position of the first quartile is 12.5, and 12.5 term mean that we can find the first quartile values by using this formula: 12th value plus, so 12th value plus 0.5 into 13th value minus 12th value. So dear students, note that this point is very important, that since the position of the quartile 1, the first quartile is 12.5. So first of all check the position 12th in the cumulative frequency row. So you see over here, actually this cumulative frequency means that from position number 1 to position number 2 this value lies, and similarly from position number 3 to position number 5 this value lies, and from position number 6 to position number 11 this 6 value lies, and from position number 12 to position number 36 this value lies. So the values is 58, 59, 60 and 61. So dear students, note that from position number 1 to position number 2 58 lies, and from position number 3 to position number 5 59 value lies, and from position number 6 to 11 60 lies, and from position number 12 to position number 26 61 lies. So it's mean that at position number 12 we have 61, and at position number 13 we have again 31. So by using this expression, the 12th value is 61 plus 0.5 into 61 minus 61, since the 12.5 position lies in this range. So this is the position for the term 12.5. So from position number 12 to position number 26 we have 61. So at position number 12 the 12th value is 61, and similarly the 13th value is also 61. 61 lies at 13th position also. So 61 minus 61 is 0. So the first quartile is 61. Now for the third quartile, the position of the third quartile by using this expression 3 into n plus 1 divided by 4, since there are 49 terms, so 49 plus 1 50, 50 divided by 4 mean 12.5, and 12.5 multiplied 3 we obtain 37.5 terms. So again using this expressions, the Q3 value lies at these position 37th value plus 0.5 and to 38 minus 37. So dear students, note that 37.5 position lies in this range, This is the cumulative frequency. So this range show that from position number 37 to position number 41 63 value, this values lies. So if we put this the result if we put the value in this expression, like you see over here, 37th value plus 0.5 into 38 value minus 37 value. So 63 lies at 37 position and also at 38 position. So 63 minus 63 will be 0, and 0 multiplied 0.5 again 0, and the 37th value, like you see over here, 37th value is 63. So the third quartile is 63. Now the quartile deviation is equal to Q3 minus Q1 divided by 2, and this is equal to 63 minus 61 divided by 2, so this is equal to 1. And the coefficient of quartile deviation, Q3 minus Q1 divided by Q3 plus Q1 is equal to 63 minus 61 divided by 63 plus 61 is equal to 0.016. So this is the value of the coefficient of quartile deviation. So dear students, the next problem is to find for this data, find the quartile deviation and coefficient of quartile deviation for the group distribution data. And this data you see over here, these are the classes, age group, and number of workers. So actually these are the classes and these are the frequencies. So the first class is 20 to 25, second class is 25 to 30, 30 to 35, 35 to 40, 40 to 45, 45 to 50, 50 to 55, and 55 to 60. And these are the frequencies. Now, dear students, for this data we also need the cumulative frequency. For the cumulative frequency, write the first frequency as it is, and now 50 plus 70, 120, 120 plus 100, 220, 220 plus 180, 400, 400 plus 150, 550, and 550 plus 120 we obtain 670, 670 plus 70 we get 740, and 740 plus 59 we obtain 799. So it's mean that the total number of workers in this data is 799. Now for the first quartile in the form of group data, dear students, you see over here, first of all find the position of the first quartile, nth divided by 4. So in the form of group data, we know that the position of the first quartile will be n by 4, and the total number of workers in this given data you see over here is 799. So 799 divided by 4 we obtain 199.75 terms. So the position of the first quartile is 199.75. So dear students, the position of the 199.75 lies in this range. This is the cumulative frequency. In this position, we know that from position number 121 to position number 220, this class lies. So the first quartile lies in this class, 30 to 35. So in this class lies. And the frequency of this class you see over here, the frequency of this class is 100, and one step previous cumulative frequency for this class is 120. Now we putting all these terms, and the lower limit of this class is 30. And this formula we have already learned about the quartile deviations in group data, that we can find the quartile by using this formula. L plus L1 mean the lower limit of the class in which the quartile lies. So the Q1 lies in this class, so the lower limit of this class is 30, and n by 4 is the position. So 799 divided by 4 minus one step previous cumulative frequency for this class is 120. You see over here, for this class the cumulative frequency is 220, and one step previous cumulative frequency is 120. Now you see over here, 30 plus 99 divided by 4 minus 120, in the frequency of this class is 100. You see over here, the given frequency for this class is 100, and the step size of this class 30 to 35. In this class the step size is 5. Now after simplifications we obtain the first quartile is equal to 33.9875, which is approximately equal to 34. Now the third quartile, First of all, find the position of the third quartile, which is given by 3 n2 n by 4, and the total terms is 799. 799 divided by 4 multiplied 3, we obtain 599.25 term. So 599.25 position lies in this range, like you see over here. 599 lies in this class. So the cumulative frequency range, this range show that from position number 551 to position 670, this class lies. So Q3 lies in this class. So the frequency of this class is 120. The lower limit of this class is 45, and one step previous cumulative frequency of this class is 550. Now putting all these results in this formula, Q3 is equal to lower limit of the class in which Q3 lies. So the lower limit of this group is 45 plus 3n by 4, we obtain 599.25, and the one step previous cumulative frequency is 550 divided by its given frequency, which is 120, multiplied by the step size, and the step size in this class is also 5. So after simplifications, we obtain the Q3 quartile, third quartile is equal to 47.05, which is approximately equal to 47. Now the quartile deviations, putting the value of Q3 and Q1 divided by 2 in this formula, 47 minus 34 divided by 2, which is equal to 6.5. And similarly, the coefficient of quartile deviations is equal to Q3 minus Q1 divided by Q3 plus Q1. So 47 minus 34 divided by 47 plus 34, which is equal to 0.16. So dear students, the conclusion of this lecture is that how we can calculate the range in ungrouped data and grouped data. Like you see over here, for the ungrouped data and for the grouped data, we can calculate the range as range for ungrouped data is equal to range for the ungrouped data is equal to the largest value minus smallest value. This is for the ungrouped data, and for the grouped data we need this formula. Actually the formula is same of the range in the form of ungrouped data and grouped data. So the formula of range and coefficient of range is same for ungrouped data and for grouped data, but in ungrouped data we can find easily the largest and smallest value. So subtract the smallest value from the largest value, we can calculate the range, and similarly largest minus smallest divided by largest plus smallest, we can calculate the coefficient of range. But in the group distribution form, sometimes we have only the frequency, like you see over here in this data. These are the values and these are the frequencies. So in this case we need the classes. This is actually the group distribution data. So in the form of group data, we can calculate the range by the largest value of the highest class and the lowest value of the smallest class. So in this data you see over here, the largest class is this 32.5 to 37.5. So the largest value of this class is 37.5, and the smallest value of the lowest class, this is the lowest class, this is the highest class, and this is the lowest class. So the largest value of the highest class and the smallest value of the lowest class. So the lowest class 2.5 to 7.5. So the smallest value of this class is 2.5, and the largest value of this highest class is 37.5. So in the form of group distribution, actually we need the classes. So sometimes we have only the values and the frequency. So for the range we construct the classes. This point is very important, and then we find the largest value of the highest class and the smallest value of the lowest class. Then we can find the range and similarly the coefficient of range. And now for the quartile deviations and coefficient of quartile deviations, we can calculate the quartile deviations and coefficient of quartile deviations. First of all, we find the Q3 and Q1. So dear students, the main question is that how we can calculate the third quartile and the first quartile in ungrouped data. In ungrouped data, you see over here, in the ungrouped data, we first of all we find the position of the Q1, and for the position of Q1 in ungrouped data, we use this expression, n plus 1 divided by fourth item. So n is the total observations of the data. So total observation of the data plus 1 divided by 4 term. So if this result is divisible by 4, like you see over here, this is actually the whole number's fourth number term. So at the fourth number term, we obtained the Q1 in this example. And similarly for the third quartile, we use this expression 3 into n plus 1 divided by 4. So putting the total result, actually the total observation in this data is 15. So 15 plus 1, 16, 16 divided by 4, 4, and 4 multiplied 3 is equal to 12. So this is the positions expression, positions formula in case of ungrouped data. And sometime we have, like you see over here, frequencies. So this is the group distribution data. So in this group distribution data, we do not need the classes construction. We do not need to construct the classes. So actually sometime values and its frequencies are given. So for the Q1 and Q3, for this group data, we do not need the construction of the classes. So first of all, construct the cumulative frequency, like you see here, this is the cumulative frequency, and then find the position of the Q1 and position of the Q3, and using the same expression for the position n plus 1 divided by 4, this is the position of Q1, and for the position of Q3, 3 into n plus 1 divided by 4 term. So this is the position of the Q3. But dear students, you know that we know that we have actually three numbers which divide the data into 4 equal parts. These three numbers are called quartiles, like Q1, Q2, and Q3. So the position of Q2 will be 2 into n plus 1 divided by 4. And similarly, the position of Q1 is equal to n plus 1 divided by 4. Position of Q2 is equal to 2 into n plus 1 divided by 4. And position of Q3 will be equal to 3 into n plus 1 divided by 4. So this point is also very important. If we obtain the whole number and this result does not contain the decimal position, then for example we have 12 terms, so we can find directly the 12 number terms from the cumulative column. The 12 position lies in this column and lies in this range. But if we obtain the position in decimal form, so for the decimal form, this is the expressions for the Q1 and similarly for the Q3. Like 12.5 mean that 12th value plus 0.5 into 13th value minus 12th value, and we have already learned for this in the previous video lecture. And dear students, note that sometime we have the data in classes form, like you see over here. This is the group distribution data, and in this data we have the classes. So in case of classes, how we can find the position of the Q1 and Q3? For the position of Q1, we do not put n plus 1 by 4. We use this n by 4, and for position number for the Q3, and for the Q3 we use the position 3 into n plus 1 by 4th term. And then using this formula for the Q1 and for the Q3. For the Q1 we use L plus n by 4 minus c divided by f multiplied h. So this L is the lower limit of that class in which Q1 lies, and n by 4 is the position of Q1, and c is the one step previous cumulative frequency of that class in which Q1 lies, and this is the given frequency of the that class in which Q1 lies, and this is the step size of the class. And similarly, the formula for the Q3 is like you see over here, L plus L1 plus, sometime we write here L means the lower limit of that class in which Q1 lies, 3n by 4. 3n by 4 actually is the position of the Q3 minus C, and C is the one step previous cumulative frequency of that class in which Q3 lies, and similarly F is the frequency of that class. This frequency is already given, and H is the step size. So dear students, note that this point is very important, that how we can calculate the range in group data and ungrouped data. Group data also actually have two types. For the group data, sometime we have not the classes and sometime we have classes. So for the range, when frequency is given, we need to construct the classes for the data. And for the quartiles like Q1 and Q3, you see over here. For the quartiles, the position of Q1 and Q3 will be calculated by using this expression, n plus 1 by 4 and 3 into n plus 1 by 4. And if values and frequency are given, we need the cumulative frequency. And if the group data given in the form of the classes, so in this case we also need the cumulative frequencies. But one point is very important to note, that for the position of Q1 and Q3 we use this formula. We cannot use the expression like n plus 1 by 4 and 3 into n plus 1 by 4. The expression will be used for the ungrouped data, and n by 4 and 3 into n by 4 position expression will be used for the given group data in the form of the classes. And this is the formula for the Q1 and this is the formula for the Q3. Now this is the end of this segment. Thank you. Allah Hafiz.